A market research firm used a sample of individuals to rate the purchase potential of a particular product before and after the individual saw a new television commercial about the product. The purchase potential ratings were based on a 0 to 10 scale, with higher values indicating a higher purchase potential. The null hypothesis stated that the mean rating after would be less than or equal to the mean rating before. Rejection of this hypothesis would show that the commercial improved the mean purchase potential rating. Use alpha equal 0.05 and the following data to test the hypothesis and comment on the value of the commercial. And the after purchase ratings are 6, 6, 7, 4, 3, 9, 7, 6, and the before purchase ratings are 5, 4, 7, 3, 5, 8, 5, 6. So we're doing an upper tail test here with mu d less than or equal to 0 in the null and mu d greater than 0 in the alternative, and mu d is defined as the after rating minus the before rating. The differences are equal to 1, 2, 0, 1, minus 2, 1, 2, and 0. The mean of those 8 differences comes to 0.625. The standard deviation comes to 1.302, and if we plug those numbers into our t-statistic formula, we get 1.36 for the value of our test statistic. We're doing an upper tail test here, so our p-value will be obtained by looking at the t-distribution table and looking at the row for 7 degrees of freedom, since our sample size is 8 and the degrees of freedom is n-1. So if we look along that row in the table, we find that 1.36 lies in between 0.896 and 1.415. 0.896 has a tail area of 0.20, 1.415 has a tail area of 0.10, and so therefore the p-value lies in between 0.10 and 0.20. We're using a significance level alpha of 0.05 for the test, and so since the p-value is in the range 0.1 to 0.2, it's bigger than the significance level 0.05, and so we fail to reject the null in favor of the alternative. So there's insufficient evidence that mu d is greater than 0, which means there's insufficient evidence that the commercial improved the rating.